Hello, my name is Afiq, and today I'm gonna present to you guys about the introduction of our MIPS program. This MIPS program displays the metric based on user's input. This program also determines the sum of all the elements entered by the user. User is prompted to enter the number of rows and column maximum of 10 for their matrix. When the user inputs a number that is greater than 10, the program will display an error message to show that the maximum number of rows or columns need to be lower than or equal to 10. User is then prompted again to enter the number of rows and columns. And then, user is prompted to enter the element in their matrix. Once the user have entered the elements, the program will print the matrix and then proceed to calculate the sum of all the elements entered by the user. Last but not least, the program is terminated. For, for the overview, this program will accept the number of rows and columns from the user and lets user to input the element before displaying the matrix and sum of the matrix. Okay, that's all from me. Thank you.
Hello, my name is T. Yong Jin. I will introduce a variable declaration in MIBS code for our metric program. Basically, before we start our instruction code, we should declare our variable. At first, we should have .data. This .data means that we store the subsequent items in the data segment at the next available address. First, we have metric, and then it has dot space derivative followed by 400. This means this metric has reserved the 400 of byte in the data segment. Why we take 400? Because we store integer as a value in our metric. An integer has 4 byte, and then the maximum row and column for our metric is 10. So 10 times 10 is 100, and then 100 times 4 is 400. So that's the reason why we take 400 for our reserve in the matrix. Next, we have our string variable. It with the ASCII Z derivative and then followed by the is string which want to prot out, such as prot row, take the string, enter the number of row for metric maximum of 10, and then prot column, that the number of columns for metric maximum of 10. So we take ASCII Z because ASCII Z have the now terminator at the back of the string. If we take ASCII only, then it doesn't have any now terminator, and then without now terminator, it probably will cause some unexpected behavior or error in our program. So we take ASCII Z to save this string in the ASCII code in the data segment. So next, we have dot word, such as row count, column count, and total sum. This dot word represents that to store the listed value. 0 is our listed value as 32-bit words or word boundary. So what is the purpose for row count? Is for storing the number of rows. And then for column count is for storing the number of columns. Last, for total sum is for storing the sum of the element in our matrix. So that's all for the variable declaration. Thank you.
Hello, I'm Haris. So today I'm going to explain about main function and error. So under .text we have a label called main function. First thing we're going to initialize total sum to 0. So we're going to load immediate 0 to $T1, and then we're going to store it inside total sum. Next step is to prompt user to enter the number of rows. This number 4 indicates that we are going to print a string, which is from row. And then this number 5 indicates that we are going to read integer from the user. Then we will store the integer inside the row count. Same thing goes to number of columns. And then we are going to check if the entered rows and columns are within the limit. First thing, we are going to load the integer from row count into the $77, and then we're going to do the same thing for column count. And then we're gonna check whether the $77 is bigger than 11. If it's bigger than 11, we're going to move to error. Same thing here. And then we're going to do the next step, which is from the user to enter matrix elements. This number 4 indicates we're going to print string, which is from element. And then lastly, for error message, we're going to print error message, which is indicated by the number 4. Lastly, we're going to jump back to the main function. Thank you.
So this is our MIPS code. I will explain in mask, so that will be easier. So at first we have this. We start from here. We load the immediate of 1 into T5. This T5 is our row index, and then we start from outer loop. We have this branch greater than, and then this branch greater than means that is it T5 is greater than T7 or not. If not, it will go to next line of instruction. This here. If does, it will go to print metric. You will go to here, print metric, and then start printing the number of metrics. So let us assume that T7 is the number of row that defined by the user. So we assume that T7 is 2. So previously we know that T5 is 1, right? We assign 1 to T5, so does 1 is greater than 2 or not? It's not. So we go to next instruction. We do the immediate of 1 into T6. This T6 is our column index, or the J. Then we come to the inner loop. Same with previously, we have this branch greater than. We check, is it T6 is greater than T8 or not? If does, you will go to exit inner loop. Go to exit inner loop here. So the T8 is the user defined the number of column of the matrix. So we assume that this T8 is 3. Okay, so is it 1 greater than 3? Is not. So we come to next instruction. This load the address of 4 to V0 is called the system to print out the string. So what we print out, we print out the string from the proc element 1 to the terminal by using this format. So what we print from to the terminal, proc element 1, we put the string in the proc element 1, there's the enter elements to the terminal, and this is called. Next we print the current row and column index. First we load the immediate of 1 into V0. This one means that I call the system to print out an integer. So and then we move the T5 into A0, and then this call the system to print out what's the number in the T5 into the terminal. So since our T5 is 1, so it will print out 1, and then basically it's totally same. Load address of 1 into V0, move the T6, the column index into A0, and then print it out. So our T6 is 1, and then we load the immediate of 4 into V0, call the system to print a string. We print the string from the proc column. So what is the string per column? Is this, just a column and then subspaces. So you come to here. So this is the overall we will print out. Then we add 1 to the number of to the column index. So this is like J++ in the C++ language. Next, we read and store the enter element into the matrix. First, we do the immediate of 5. This 5 is called the user to input in the terminal. So this is called the user to input the terminal, and I store the value that input to the v0. Okay, the value that inputted by the user into the v0, and I store this v0 into this 0 effective memory address. So for example, if I have 1, I save 1, so this one is come to v0, and then this value of 1 will save into 0, and then since the t1 is 0, so it will come to 0 effective memory address. Next, we will load the word of total sum into t1, and then we add the value that user input into t1. Then we store the value of t1 back to the total sum. So, and last, we add the immediate of 4 into t0. Why we need to add a 4? Because this is our effective memory address. For example, this 0, and then we add 4 to save the data into the next effective address, by so on. So there's a reason why we add the 4 to prepare for the next user input value. And then next we jump to the inner loop. We jump back to inner loop, and then since we just now have add our column index, so our column index has become 2. So thus the column index of 2 is greater than 3 or not. It is not, so it completely looping again. So for example, we start from here. We have previously same, so we print a row and column. Just print a row. Since our row index didn't modify anything, so it still print once, and then come to here to print the integer. Since our column index has +1, so it could become 2, so it will print out 2, and then anything other else are set. For example, I input 2, and then for my user input, I save a 2 into v0, and then v0 to the 0, and then st0. And then we notice that we have add 4 into our t0, right? So in final, we save 2, and previously we save 1, so 1 will be here, and then 2 will be saved in here, and then +4 so on. The next number of value was saved in here, next number was saved in here, so on. So after just looping. So let's take 3, 4, 5, 6. Okay, so yeah, like that. My first value is 1, so it will save in here, and then after by +4, the value will save in here, plus 8, 4 plus 4 equal to 8, and then save it here. So you save it by sequencing, and then come to here, jump back to the inner loop, and then if 3 is greater than 3 or not. It's not, so it will come to again, and then j plus 1, and then +4 of the memory, save the user input data, prepare for the user input data to save it into the next location, and then jump back to the inner loop, and then let's assume that this ready for. And then is it 4 greater than 3? Yes, it does. So it will come to exit in the loop. Come to here, exit in the loop. We have add I at the immediate of 1 into t5. Send it I++ in C++ programming. So after I add it, I jump back to the outer loop. And then thus 2 is greater than, since we have I++, so t5 will become 2, and then does 2 is greater than 2 or not? It's not, so it will completely um, do the instruction that I explained before. Come to here, do the reinitialize the column index into 1, and then come to inner loop, check is the column index is greater than the user defined input number of column or not, and then come here, print out the text, the string, print out the number of the row and the column, and then the colon, and then J++, read and store the data into metric, and so on. Repeat until I come until the T6. Okay, the T6 is 4, and then our T8 is still 3, right? So is it 4 is greater than 3 or not? It does, so it will come to exit inner loop. It will come to exit inner loop, and then add plus again, plus 1 to T5 again, then jump back to outer loop, and then at here our T5 will become 3. So we will check, does 3 is greater than 2 or not? It does, so 3. So we will come to print metric. We'll start printing the metric. Start printing our metric. Yeah, so that's all for how does the MFS code save the user input data from the metric, and then how the looping working. So that's all. Thank you so much.
Assalamualaikum, I am Nurkila Alia. So for the print matrix label, it will load the address of the matrix array into register T0, and then it will print out the label of your matrix is from the matrix print variable, and then it will initialize register T5 equals to 1, which in terms of C++, it will be the counter I. Continuing to the print matrix outer loop label, it will check whether the register T5 is greater than register T7, and if it is true, it will branch to the exit label. So to make it easier to understand, it will check whether the counter I is greater than the number of rows. And if it is true, then it will stop printing the elements of the matrix, and then if that is not the case, then we will have to initialize register T6 equals to 1 or counter J equals to 1. For print matrix inner loop label, it will branch to the inner loop N label if register T6 is greater than register T8, or if the value of J is greater than the number of columns. However, if branching did not occur, it will continue to print the elements of the matrix and perform increments to register T6. After that, it will loop back to the print matrix inner loop label to check the conditions. Once the branching for the inner loop n occur, it will print out a character, which in this case is \n, which will print out a new line so that the elements will be printed on the next row. Then it will perform increments to register T5 and jump back to print matrix outer loop label.
Okay, this is for sample output of our group project. It will ask the user for enter the number of rows for matrix, maximum of 10. Second, it also will ask enter the number of column for matrix. If user enter digit maximum over 10, it will call error and it will reset coding matrix. Okay. After that, it also asks user to enter the number of row and matrix, and that it also asks the user to enter number of column for the matrix. Okay. Next, and it will ask the user to enter element of matrix in digit 1 for the rows and digit 2 for the columns. Okay, next. The coding will show the matrix. Lastly, coding will show the sum of all the elements that there are. This okay, this is for our group. Okay, thank you.